maximum average drag force. So the hint here is there's no drag force at the start and a maximum drag force at the end. So this one kind of expands a bit more on the previous questions, looking in a little bit more detail exactly what's happening to the drag force. Because previously we've been treating the drag force as more or less constant, and then all of a sudden it equalizes at the end. But maybe we'll be a little bit more accurate now and have a look and recognize that the drag force is a force which changes. So at the beginning, when the car starts moving from rest, there's a force which drives the car forward. I'll call it the thrust, T. And there's no drag force at the very beginning because the car's not going that fast, so there's not much air resistance. But then later, when the car's reached its top speed, it's no longer accelerating. So it must be that the drag force has equalized and become equal to the T, because the car's not accelerating. So this is Newton's law. But the drag force, is it right to say that the drag force is 0 or T? Well, no, because it's changing. So what we'll say is the drag force is roughly the average, which will be 0 plus T over 2, which will be T over 2. But what is the T here? So that is, what is the acceleration here of the car? Well, not the net acceleration, of course. The T is the thrust, the driving force of the car, which we can get from looking at the net acceleration. So to get the T, that's equal to force. But what exactly force is it equal to? Well, we can say that F equals ma. We know the m, it's 1200, and we can work out the a. But what's the total force here? Well, it'll be T minus the drag force, which we just said is on average T over 2. So that means T over 2 is 1200A, so T is 2400A. The U is 0, the V, the A, the T, the S. Okay, so the V is, I think, 160 kilometers per hour though. The A is what we want. T is 20 seconds. So let's just convert that into meters per second. So that is that many meters in an hour, that many meters in a second, 44.444. And we're looking for the A, so we'll go with V equals U, which is 0 plus A T. So just take that answer and divide it by 20. So that is 2.22 meters per second squared. Okay, so just multiply that by 2400. And we get 5,333 newtons. That's the driving force of the car, and the drag force is roughly half of that. So we can say that T is 5,333 newtons, and then D is 2,667 newtons then. Okay, so that's that one then.